everyone. I, Dr. Padmini Sharma, welcomes you all to SWAYAM online course on maintenance and testing of electrical machine. In the previous classes, we have discussed different protection technique for transformer and transmission line. Overhead transmission line has a greater fault incidence rate than the other crucial component of electrical power system because of its mostly exposed to the ambient condition and of their greater length. But on the other hand, the chance of fault occurring on the transformer are very rare. However, the consequence of even a rare fault may be very serious unless the transformer is quickly disconnected from this system. Under the protection of transformer, we have discussed the Buchholz relay, which is the gas operated device installed in oil merged transformer to protect against incipient fault. To address earth fault and face-to-face fault, transformers usually have combined protection for both leakage and overloads. Next, we have covered differential protection method, which is widely used for transformer protection due to its high reliability and sensitivity in detecting internal faults. Although Buchholz relay can identify internal transformer faults, differential protection scheme can do more quickly or more faster. So, even though the differential protection provide the best overall protection, but some factors such as CT saturation, mismatching CTs, inrush current, CT connection affect the differential current in a transformers and should be considered while applying differential protection. These factors can result in a differential current even under balanced power in and out condition. To overcome this difficulty, some of these difficulty, percentage differential protection technique is used, which is the advanced form of simple differential protection relay for overcome the some of the difficulty faced by the plain relay like CT mismatch, CT characteristic, etc. So, under the next is the protection of transmission line. Under the protection of transmission line, we have discussed time graded overcurrent protection is a method used to protect transmission line by coordinating the operation of protective device so that the device close to the fault operate first, that minimizing the impact of the fault on a power system. Next, under the distance relay, we have discussed about the impedance relay, and that relay measure the impedance between the relay location and the fault point where the incident and where the fault is incident and compare it with the set value. If the measured impedance is less than the set value, the relay operates and isolates the faulty section. But in actual practice, it is not possible to obtain instantaneous protection for complete length of line due to inaccuracy in relay element and instrument transformer characteristic. These difficulties overcome by using 3-zone distance protection. The zone protection distance is an effective and reliable method for protecting transmission line. Next, under the transmission line protection, we consider the merge price voltage balance protection under the differential pilot wire scheme. So, this is all about the summary of last 2 lectures. In this, we cover the protection technique of transformer and transmission line. Both are very important element of our power system. Next, now in today's class, we will be going to cover protection technique of very important power system element or component, that is the rotating electrical machine. Let's start discussion about that particular topic. So, a rotating machine refers to any device that convert mechanical energy into electrical energy or vice versa through the rotation of its component. This machine plays a fundamental role in various industrial and commercial applications where they are used either to generate electricity or to derive the mechanical load. Rotating machine can be categorized into the main 2 types. One is the electrical motor and another one is the electrical generator. Electrical generator convert mechanical energy into electrical energy. It is specifically synchronous generator or alternator and are crucial for generating energy. Next is the electric motors. It converts electrical energy into mechanical energy. It is significant as large load in electrical system. It is specifically synchronous motor or induction motor. Before going to cover the protection method of rotating machine, let's revise their basic component that is required for their protection. Knowledge of the basic component of rotating machine is required for their protection purpose. The basic construction and structure of all AC rotating machine is similar. A typical rotating electrical machine consists of two main parts, namely stator and rotor. The stator and rotor are separated by an air gap. As the name implies, the stator is the stationary or non-movable part of electrical machine. In general, the stator is the outer frame of the machine. The rotor is the rotating part of the machine. Both stator and rotor are constructed by using laminated ferromagnetic material to reduce the reluctance in the path of magnetic flux. All rotating electrical machine consists of two windings, one placed in the stator part and another on the rotor part. The winding on the machine in which the voltage is induced or applied is known as the stator winding. The winding which is used to produce the main working magnetic flux in the machine is known as the rotor winding. Now, after knowing the basic part of the rotating machine, next we move toward the what are the protection and why the protection of rotating machine is required. The protection of rotating machine such as synchronous motor or synchronous alternator or generator is crucial to ensure their reliability and safe operation. Protection scheme for rotating machine are designed to address both electrical and mechanical faults. These protective measures ensure the machine's durability, reliability and safety by detecting the abnormal condition and triggering appropriate action, such as disconnecting the machine from the system. Alternator is the heart of the power system is an apt metaphor because such like the heart in a biological system, the alternator play a central and vital role in the operation of entire power network. Just as the heart pumps blood throughout the body, the alternator generates the electricity that flows through the entire power system. Alternator, especially those used in a large power plant, are expensive and complex machines. Their repair or replacement is costly and time consuming, making protection against fault crucial to avoid financial losses. The protection of an alternator is often integrated with other protection schemes in the power system, such as those are transformer, transmission line and distribution network. Proper protection of an alternator is essential to ensure that the overall effectiveness of these protection scheme. Hence, the protection of an alternator is more important because alternators are critical to the generation and stability of entire power system. Their failure can lead widespread outage, significant financial losses and potential safety hazard, making their protection a top priority in power system management. So, our discussion will mainly focus on the alternator protection technique. Next is what are the type of fault in a rotating machine. The primary parts of fault in rotating machine categorized into stator faults and rotor faults. Stator faults further categorized into phase-to-phase fault, phase-to-ground fault, interturn fault. Phase-to-phase fault occur when insulation between two phases of winding fail, leading to short circuit between the winding. This can cause significant damage due to high fault current. Next is the phase-to-ground fault. This fault happens when the insulation between the phase winding and stator core fails. This can lead to ground fault, which may cause severe damage if not promptly detected. Third one is the interturn fault. These faults occur between turn of the same winding, leading to a localized short circuit. Through initially small interturn fault can rapidly increase and cause more severe damage. Next is the rotor faults. The fault that exists in the rotor can be either earth fault or an interturn fault. These faults can be primarily caused by the mechanical and thermal stresses affecting the winding insulation. Next, we discuss about the different protection technique which is used for stator fault. Stator winding faults are particularly dangerous and can cause significant damage to expensive machinery. As a result, automatic protection is essential to quickly clear this fault and minimizing the effect of the damage. The most common system used for protection of stator winding fault employ differential protection or circulating current, which is based on the circulating current principle. It is used for protection of the generator against phase to earth and phase to phase fault. Differential protection is based on the circulating current principle. We have already discussed the working of differential protection technique in transformer and transmission line protection. Identical current transformer are in alternator. Identical current transformer are placed on either side of the phase of the stator winding. The relay recommended for this application is instantaneous attracted armature type, which is immune to AC transient and has high speed feature if the CTs are responsively matched. Under the normal operating condition, the current at both end of the each winding will be remain equal. But when an earth fault or phase to phase faults occur, this condition is no longer hold good and the differential current flowing through the relay circuit and operate the relay to trip the circuit breaker. We already know that due to some factor like CT, mismatching characteristic, we can use the improved form of differential relay, that is the bias differential protection scheme. Under that, we use the restraining coil so that it will result in a high amount of spill current flowing through the relay. Figure show the schematic arrangement of bias differential protection of a three-phase alternator. So, with the help of differential protection of biased percentage differential protection, we can save our stator winding for phase to phase and phase to earth fault. But this differential protection have some limitation, which is it is in general practice to use natural resistant earthing in order to avoid adverse effect of earth fault current. Due to this, the fault current is very less when the ground fault happen near the neutral point, as the voltage is very less. So, simple differential protection scheme cannot detect the fault. In such a situation, it is impossible to protect whole the stator winding of a star connected alternator during earth fall. It is usual practice to protect only 85% of the winding because the chance of earth fault occurring near the neutral point are very rare due to the uniform insulation of winding throughout. This is the limitation of differential protection scheme. Next one is the modified differential protection scheme. If the neutral point of star connected alternator is earthed through a high resistance, simple differential protection scheme will not provide sufficient sensitivity for earth fault. It is because high earth resistance will limit the earth current to a low value, necessitating relay with low current setting if adequate portion of generator winding is to be protected. However, if the current setting is decreased, so it maloperated during the high through fault due to the difference in CT characteristic. In order to overcome this difficulty, a modified form of differential protection is used in which the setting of earth fault is reduced without damaging the stability. Under that, separate earth fault relay is used to detect the ground fault. So, this problem we faced when the Neutral of the alternator or rotating machine is grounded through the high resistance winding. Under the modify differential protection, the modification involves change only to the relay connection. Specifically, two relay are chosen for phase fault protection, while the third relay is dedicated to earth fault protection. The two phase element PC and PA along with the balancing resistor are connected in a star configuration, and the earth relay is connected between the star point and the fourth wire of the circulating current pilot scheme. If earth fault occur on any one phase, the out of balance secondary current in CTs in that phase will flow through the earth relay by pilot S1 or S2 to the neutral to the current transformer. This will cause the operation of earth relay only. If a fault occur between the two phase, the out of balance current will circulate around the two transformer secondary via any of the two coil PA, PR or PC without passing through the earth relay ER. Therefore, only the phase fault relay will operate. So, by this protection, we can protect the fault of whole stator winding. Balanced earth fault protection. In a small alternator, the neutral end of the three-phase winding are usually connected together internally to a single terminal. Because of this setup, it is not possible to use the merge price circulating current method for protection, since you can't install the necessary CT on each transformer's neutral connection. Instead, a balanced earth fault protection scheme is used to detect earth fault. However, this method does not protect against fault between the phases. Figures show the schematic arrangement of balanced earth fault protection for a three-phase alternator. It consists of a three-line current transformer on one mounted in each phase, having their secondary connected in parallel with that of a single current transformer in the conductor joining the star point of the alternator to the earth. A relay is connected across the transformer secondaries. Under normal operating condition, the current flowing in the alternator leads, and hence the current flowing in the secondary of the line current transformer add to 0 and no current flow through the relay. Also, under this condition, the current in the neutral wire is 0 and the secondary of neutral current transformer supply no current to the relay. If an earth fault develop at F2 point external to the protected zone, the sum of current at the terminal of alternator is exactly equal to current in the neutral connection, and hence no current flow through the relay. When an earth fault occur at F1 or within the protected zone, these currents are no longer equal and the differential current flow through the operating coil of the relay. The relay then closes its contact to disconnect the alternator from the system. Next one is the stator and interturn protection. Differential protection is ineffective for interturn faults because the current at both ends of the winding remain identical. In single turn generators such as large steam turbine generator, protection against interturn fault is generally unnecessary. However, interturn protection is essential for multi-turn generator like hydroelectric generator which features double winding armature. It means each phase winding is divided into two halves due to extremely high current they must handle. This result to another modification in the protection of differential relay. The figure showed the schematic arrangement of circulating current and interturn protection in a three-phase double wound generator. The stator winding split into S1 and S2 of each phase are equipped to guard against interturn fault. Two current transformer CTs are connected using the circulating current principle. Under normal operating condition, the current in the stator winding S1 and S2 are equal. resulting in identical current in the secondary of the two CTs. Consequently, the current around the secondary loop remain the same at all points and no current flow through the relay R1. However, if a short circuit occur between adjacent turns such as within S1, the current in the stator winding S1 S2 become no equal. This imbalance induces the unequal current in the secondary of CTs, causing the difference in this current to flow through the relay R1. The relay then activate, closing the contact to disconnect the generator from the system and thus protecting it from the potential damage. So, this is all about the stator fault protection technique, where we basically use differential protection and each condition we modify that differential protection. Next, we move toward the rotor fault protection technique. Rotor fault can be categorized as either earth fault or interturn fault. These faults are primarily caused by the mechanical and thermal stresses affecting the winding insulation. As the field is ungrounded, a single fault may not cause immediate issue. If a second fault occurs, a part of the field winding is bypassed, increasing the current through the remaining portion of the field winding. This causes an imbalance in the air gap fluxes, creating a worry in the magnetic forces on opposite side of the rotor. This imbalancing in magnetic forces make the rotor shaft eccentric and cause vibration in the rotor shaft. For the protection against the rotor fault, DC injected method is used. In this method, one terminal of DC voltage sensitive relay is connected to the positive terminal of the exciter and the other terminal is connected to the negative terminal of the external DC source. This DC source is provided by an auxiliary transformer with a bridge rectifier with its positive terminal grounded. It is also seen from the figure below. At the event of any field fault or exciter earth fault, the positive potential of the external DC source will appear to the terminal of relay which was connected to the positive terminal of exciter. In this way, the rectifier output voltage appear across the voltage relay and hence it operate. After the stator fault protection, rotor fault protection, there are some abnormal running condition also arise in a rotating machine. The abnormal running condition that can occur are loss of excitation, unbalanced loading, over voltage, failure of prime mover, over speed and over voltage. So, care of these abnormal condition is also very important for rotating machine, starting with the failure of prime mover. The prime mover is an alternator is the critically important because it serves as the source of mechanical energy that the alternator convert into the electrical energy. So, when the prime mover fails, the machine begin to operate as a motor, drawing real power from the system and driving the prime mover. A reverse power relay can be used to detect the tripping characteristic in this type situation, since there is a change in the direction of flow of power working over the full power factor range. So, reverse power relay is used for protection against the prime mover failure. Next one is the loss of excitation. Loss of excitation in generator occur when the excitation system fail, causing the generator to run above the synchronous speed. When the excitation is lost, the generator can no longer produce the necessary magnetic field, causing it to behave like an induction generator. It takes required reactive power from the grid and supply active power. This causes overheating in the circuit. On the loss of excitation, the current increase and the impedance decreases, which can be detected by the offset mode relay, which is the type of distance protection technique. Third situation is the unbalancing loading. Unbalancing loading means that there are different phase current in the alternator. Uneven distribution of load and ground fault, line to line fault or line to ground fault can cause unbalanced loading. An unbalanced loading situation give rise to negative sequence current in the rotor circuit. The negative sequence heating follow a normal resistance law and hence is proportional to the square of the current. Due to this heating, hysteresis and eddy current losses also increases. For protection of this unbalanced loading, negative sequence filter provide with the overcurrent relay is used for against the unbalanced loading. In this type of protection, 3 CTs are connected to 3 phase and the output from the secondary of CTs feed to the coil of overcurrent relay through negative sequence filter. Negative sequence circuit consists the resistance and capacitor and these are connected in such a way that negative sequence current flow through the relay coil. The relay can be set to operate at any particular value of unbalanced current or the negative sequence component current. Next one is the overspeed protection. Overspeed protection is an alternator is a critical safety feature designed to prevent the alternator from operating at speed higher than the design maximum. The chief cause of overspeed is the sudden loss of all or the major part of the load on the alternator. Modern alternators are usually provided with mechanical centrifugal device mounted on their driving shaft to trip the main value of prime mover when the dangerous overspeed occurs. Next is the overvoltage. The field excitation system of modern alternator is designed to prevent overvoltage condition at normal operating speed. But when a large portion of the load is suddenly disconnected from the alternator, the reduced load current cause the alternator voltages rise sharply. Persistent overvoltage can cause the insulation of the winding to deteriorate or fail, leading to short circuit and other fault. Equipment connected to alternators such as transformer and motor can be damaged due to sustained overvoltage condition. For protection of overvoltage relay is used. These relay monitor the terminal voltage of the alternator. If the voltage exceed a preset threshold, the relay triggered protective action and it is typically set to operate if the voltage exceed the normal operating range, usually 110 to 120% of rated voltage. Upon detection of overvoltage, the relay may initiate the tripping of the alternator, reduce the excitation or activate the alarm to alert operation. So, this is all about the protection method or technique involved for protection of rotating electrical machine. Our mainly concern on the protection of the alternator because it is the heart of the power system. Let's revise the whole method. The protection of rotating machines such as synchronous motor and synchronous generator is crucial to ensure reliability and safe operation. Protection scheme for rotating machine are designed to address both mechanical and electrical fault, and protection of alternator is more important because alternators are crucial to the generation and stability of the entire power system. Their failure can lead to widespread outage, significant financial losses and potential safety hazard. Making their protection is a top priority in power system management. Primary type of fault in rotating machine categorized into stator fault, rotor fault and some of the abnormal condition. Mostly stator winding fault are protected because it is very dangerous with the help of differential protection technique. Differential protection technique, we already know that it is based on the circulating current principle, but it is general practice to use the neutral resistance earthing in order to avoid the adverse effect of earth fault current. Due to this, the fault current is very less when the ground fault happen near the neutral of the voltage is near the neutral because the voltage is very less. So, simple differential protection scheme cannot detect the fault. In such a situation, it is impossible to protect whole the stator winding of a star connected alternator. It is usual practice to protect only 85% of the winding. In order to overcome this difficulty, a modified form of differential protection is used in which the setting of earth fault is reduced without damaging the stability. Under that, separate earth fault relay is used to detect the ground fault. The modification involve change only to the relay connection. Specifically, two relays are chosen for phase fault protection, while the third relay is dedicated to earth fault protection. Another difficulty faced in a small alternator, the neutral end of the three-phase winding are usually connected together internally to a single terminal. Because of this setup, it is not possible to use differential or merged price circulating current method for protection, since you can't install the necessary CT on each phase's neutral connection. Instead, a balanced earth fault protection scheme is used for detecting earth fault. Rotor fault are primarily caused by the mechanical and thermal stresses affecting the winding insulation. As the rotor field is ungrounded, a single fault may not cause immediate issue, but if a second fault occurs, a part of the field winding is bypassed, increasing the current through the remaining portion of the field winding. For protection of rotor against such fault, DC injected method is used. Now, to overcome or to handle the abnormal condition like failure of prime mover, a reverse power relay is used to detect the tripping characteristic in this situation, since there is a change in the direction of flow of power over the full power factor range. Next, the loss of excitation in a generator occur when the excitation system fail, causing the generator to run above the synchronous speed. This cause overheat the circuit. On the loss of excitation, the current increase and impedance decrease can be detected by offset move relay. Under the unbalanced loading, it rises to the negative sequence current in the rotor circuit. Negative sequence filter provided with overcurrent relay is used for protection against the unbalanced loading. So, this is all about the today class. We cover mostly all protection technique which is used for the alternator protection. Thank you all.